Hello, and welcome to week three. I am the only one here right now. I'm sure someone will show up before the end of the class. But I'm gonna go ahead and get started because it's 9:35 now, and I want to make sure I get all this information out for you guys. So let me go ahead and share my screen here. I never remember how to share my screen. There used to be a big share button in the middle now. No, it's not there anymore. Um, oh, there it is. Okay. All right. So let me minimize this. So today we're going to talk more about database structure. And we're going to talk about normalization and what exactly that is and why we use it. And we're going to talk about joins, and we're going to do some more work on the database we're creating in class, which is the shelf indulgence bookstore. So just so you know, normally it's in week three where we got to talk about the final project today. We got to do that. Actually, we'll probably do that first. Um, so let's talk about the final project first. So we're there. Okay. Um, as I said in week one, you've got a choice coming up to you, and that is, do you do the final exam or do you do the final project? Uh, the final project is taken during weeks 13 and 14, or whenever you get around to taking it, and it is a comprehensive assessment of SQL syntax and coding and stuff. It is a accumulation of the what you've been taking in the quizzes. So it's the same question bank that are in the quizzes. Um, so it's the same deal too. It's open book, open notes, open friends, whatever it is. Take the test the same way you take the quizzes. I think you've got two chances to do it, but it's 180 questions. Um, it's a lot. I don't know if it's 180 minutes, but it's not. I don't know how many questions it is. But you may not want to take it again. But it's that. So the other choice is the personal capstone project. So what the capstone project is, or the final project is, a is you will design a database from scratch for something that either you think needs to exist in this world or something like a lot of students have family and friends who run businesses that don't have databases. So they design databases for them. And that's all valid. If you're working on a project in another class that requires a database, I'm totally cool with using that too. Whatever helps you get those creative juices flowing to create the database, I'm totally cool with. It takes roughly 10 weeks to do this from start to finish. Because you'll be designing the concept, the database, the tables, the queries, the constraints, all that other stuff. That's all going to be in there. So you gotta design that, and there's a bunch of other things you need to do. So don't start later than week. If you start later than week six, technically you can. Um, but it kind of puts you in a bind. And again, if you choose to start, hang on a second, the final project, and something comes up to where you can't do it, then that's totally fine. Go back to what you were doing before the final exam. I'm not going to hold you liable for that. Why would you do the project? Well, it gives you a portfolio ready database to show to someone that you designed. You can go to any potential employer, you can put it up on GitHub so someone can look at it. I mean, a lot of students don't even go into the real world with stuff like that, so that's great. You can get some scripts out on GitHub, and it's like, and the thing is, this isn't just a homework assignment. You're building a database that you care about, something that you think is important, something that makes a difference to you. So I do strongly suggest doing the final project if you've got the time. Um, just make sure that you at least check in with me from time to time. Oh, so by the way, speaking of checking in, so if you do choose to do the project, instead of doing the normal weekly assignment with Possum Pets database, you don't do those anymore. If you're doing the final project, you'll instead use that weekly assignment as a conversation with me to make sure that that you're letting me know how things are going, where you're at, what's going on in that world. Do you need any help? Ask me any questions, show me your progress, and I'll give you feedback on it. Like show me your ERD, and I'll tell you like this is good, this is not good. Work on this, not quite there yet, right? So what are the instructions for this? We go right here. Okay. The first thing you must give me is a business concept proposal. And this all gets submitted on week 13. Okay. The business name and the purpose of the business, the functionality of the database and what the purpose of the data is, describing the tables that you're going to be using, and the ERD, the energy relationship diagram. That is the first thing you'll submit to me. The second thing you'll send me is the database schema. Now, what I want for this, when I say this, I want the code that you use to create the database. So for every foreign key, for every primary key, for every the all the scripts, everything that was used to create the table. So that would be the creation of the databases, the creation of the tables, the creation of indexes, all that stuff. I want that submitted to me. The third thing I want you to send me insert statements to put 10 to 15 rows of data in every table, maintaining referential integrity, and give me the scripts for doing so. Okay. Because when I grade this, what I do is I run this code to create the database, and then I run this code to insert it, and then I run all the other codes to make sure they work. The fourth thing you send to me is you give me examples of create, read, update, and delete functionalities for your database. So you're gonna create is insert, so there's no create commands. So you're gonna insert date rows. You're gonna give me selects, simple updates, simple deletes. So for example, inserting a new row, registering a customer profile, or adding a new product or service to your inventory. Select looking up all orders placed by a specific customer, finding all appointments scheduled for a certain date. You want to modify the rows and then show an example of deleting them. Okay. So you're going to give me uh, probably three or four. Hey, Wilford.
Hey, how's it going? Sorry I'm
Good.
late.
Oh, no worries. I just wanted to get started with you because I had a lot of information. So I'm just randomly going over the final project, what the expectations are for it. I'll
Cool.
back up a little bit. So it's just so the final project's in lieu of the final exam. You are tasked with creating a database from scratch on your own, on whatever topic you want it to be on. Something that you're passionate about. If you've got a family member or a loved one who it has a business without a database, you can design a database for that. But it's got to be something of your own volition. It's not like I'm gonna recreate Family Search. Like it's whatever you want it to be. Um, and this is in lieu of the final exam. Also, when you do this, you stop doing the possum pets exercises as listed, and that assignment becomes a conversation with me on how you're doing with the assignment, how the project's going. Do you have any questions? Get some feedback from me. I'll ask you questions about what's going on, how things are going. Just I want to keep that. If you're going to do the final project, it requires a more of a continual conversation with me because I want to make sure I'm guiding you through it. Because it can get frustrating. The first thing you submit to me in your final project is a business concept proposal. Uh, just a quick one-page document, like a elevator pitch, what the database is, what the purpose of it is, what business it's supporting, what's the functionality of what data you're storing in there, and why are you storing it. Give me descriptions of the tables and give me the diagram of the database. I'll explain what the ERD is as we go along. I'll show you how to make those, but it's a very simple thing. Um, then I need the code that you use to create the database. I strongly recommend that you use the GUI in the workbench to create it rather than code it out, because then you can just drag and drop everything and just force the code and it'll write the code for you. Or you can, write the code cold, whichever way works. But I need that code of how to create the database because what I'm going to do is when I grade it, I'm going to take that code and create the database on my machine and see if everything went fine. Then I need the code to populate the database, 10 to 15 rows for each table. Make sure the integrity is there, make sure the scripts are there. Just give me all that so I can populate the table. Then I need CRUD operations, and CRUD operations is very basic. We're going to talk about those today. We've already done the select statements. We've already done all of these. Just very basic statements for each table to insert, select, update, and delete rows from those tables. The next thing is I need you to create business cases. A business case is an advanced query or a view that meets a specific repeatable purpose for the customers or the business. So, for example, let's say you were make it simple. I've been building out that shelf indulgence bookstore database. So let's say one of the things we want to know is what genre of books sells best during which month and which one sells worse. So I would create either a stored procedure, an advanced query that returns the best-selling books by month. Or I'd create a view, and a view is we'll talk about those in a couple weeks, but a view is a permanent query that exists in your database that always returns the same ask for data. Okay. Um, we'll get to those. They're very cool. They're hard coded in the table. It's like a query that's hard coded and repeats every time with new data because it pulls from the underlying tables. Um, and so
Are
in
they
the
like essentially like template queries? Are they like repeatable, executable, and it'll like
that's
display it the same way every time?
it's exactly what they are.
Yeah.
Yep,
Nice.
exactly what they are. So, and the one thing I'm going to talk about probably week 8 is something that's not covered in the course. We're going to talk about how to create a stored procedure. A stored procedure is it's in coding terms is a function. So you can create functions. I hate to use the word function when it comes to database because there are functions in SQL that aren't like functions in programming. But in coding terms, if you code in C# or something like that, if you create a function, so it's a repeatable piece of data that just does the same thing every time. Just pop the data into it. So we'll make those, and then why you did those. So, like I said, for example, I want to write 3 advanced queries using aggregate functions. So I want to find out all my sales by genre every month during a year. So I'll get that big, wonderful query up and it'll show me everything. Um, Views might be for customers. Like if I want to create a view to give me a dashboard of my customers, give me a dashboard of like my book club members or something along those lines, and then why they're there. And the last thing you give me is a PowerPoint presentation or a video presentation, 3 to 5 minutes long, that explains the project to me. I mean, imagine if we were in a classroom, all in a classroom, this would be a presentation that you do in front of the class. So rather than that, because we can't do that, just give me a video of it. So it's a lot more fun than the final exam. I highly recommend doing it, but entirely up to y'all, um, if you want to or not. Um, there are some people at this point in time who are like through week 8 in the coursework because they just want to get done with it. So obviously they're not going to do the final project. There are some, and if they ever watch this and get mad at me when I say this, there are some people who take this class who just power through and don't pay attention and then do both the final exam and the final project. Um, and they do the final project very, very badly because they never asked how to do it. So it pays to wait and ask questions. Anyway, please don't send me the database file, the MWB file. I can't do anything with it. I run a bit different versions of MySQL than you guys do. Um, Please make sure all code is in a separate document. It's either PDF or a SQL file. I don't care. But don't put the code or anything code wise in the PowerPoint presentation because I can't get it out to run it.
Mhm.
And then everything has uploaded in the final project in Canvas. So, and here's some links to do this stuff. So that's the final project. I highly recommend doing it. It's a great example. And if you ever want to get into IT, like development or database engineering, it's a great thing to throw in GitHub and show people. You know, I did this as a capstone project in my database class. I created this database, and they'll understand that it's going to be fairly fundamental. But if you're like knocking out things like stored procedures and advanced views and stuff like that and indexes, they're gonna like, hey, wait, this person knows what they're doing. So anyway, so there's that. That's the spiel on the fun project. Okay, so now we can talk about today. Um, so we kind of started talking about this last week as we were designing shelf indulgence about the normalization of data. And this is one of those things that if you decide to get in field as a DBA, it's not really talked about. It's just assumed that you understand how to do it. So normalization of data just basically means that um, there's an, an atomicity of your database, that there's no duplicate or extraneous data in the database, and there's no data in tables that it shouldn't be. So let's talk about that real quick. So we're going to talk about, I think there's like five normalization forms, but only the first three matter. So the first normalization, or the first normal form, is when the data is atomic. There's two rules. Um, each row must contain atomic or indivisible values, no lists of authors in one cell. So if I had a book, if I had a table for book, um, and I had book ID, book, and then author, right? I couldn't put like six names in the one field because there's no way to get that out efficiently. Okay. The other thing I can't do is I can't have columns. Like I can't have author one, author two, author three, and author four, because one of the two things are going to happen. Either one is there's only one author, then I got three columns that are null, taking up space. Or if I do author one, author two, what happens if there's an author three? So it's not data we can house in the book table because there's no consistency. I can't guarantee that it's atomic. Does that make sense? Like I can't guarantee there's only one. So that's the first form of normalization, to make sure that every column only contains one value and I don't have repeating columns. Like the only exception to that is like address one, address two. That's acceptable
Yeah.
because yeah. So and that's like universally accepted. Like address one is your street address, and address two
Yeah.
is like your apartment or something like that, right? So,
Quick question for you,
hmm?
not to interrupt the flow.
No, go ahead.
In a case, for example, let's say it's authors, right? If you wanted to allow for the potential of multiple authors, but you want to normalize your database effectively, could you make the data type for author an array and then just add more items into the array if you have multiple authors? Or does that cause problems?
So what you're talking so that causes problems because you're talking about to put an array into a cell. It's I can't. It's putting a database into a data. So I'll give you an example. Are you familiar with XML?
A little bit, yeah.
Okay. So XML is a markup language like HTML, but it was specifically designed to create databases um on a web page.
Yeah.
Okay. So I worked for a company called Property Insight, and we were just we were early adopters for SQL 2008, and they had just introduced the XML data type into Microsoft SQL Server. And Property Insight was a property insurance company. So we would get tons and tons and tons of data from every county across the country. And we had to take that data and put it into our database. And let's say there were 500 columns of data they brought over, but we only used 50 of them. So there are 450 columns of data that we weren't consuming, we were just throwing away. Microsoft convinced us that we needed to put that data in our database, and they convinced us to put it in an XML file. So we created an XML column, and those 450 rows of data went into that column. So what ended up happening is for every row of data, there was a separate database
Mm.
in that column. So querying that was next to impossible because there was so much in there and you couldn't index those. in a sane way. And those tables became huge because you had a separate database in there. I'm going to show you what to do in the case of book and book authors here in a second. I've got code to
Cool.
show you how to do that. But no, it's a logical assumption that you made. Like, could I just make an array? You could, but putting that in a database, I want to say the
Makes it
words in.
really difficult to index properly
Yeah,
because now
yeah,
it's, yeah,
exactly. But your train of thought is right there. Um,
cool.
so for example, in the second normal form, no partial dependency. So to reach the second normal form, all tables must be in the first normal form. And then you've got to make sure every table is dependent on a primary key. So as I said last week, the primary key is the one column in the database that is by default an index, that is by default not null. It has to have a value, and by default is unique because it's that column that is going to sort the table on what it'll be the main index that sorts the table. When if you just do a blank select star from table, it's going to come back in the order of the primary key. Okay. Now, primary keys can have one column in them or up to three columns in them. So it's not just one column, it can be a composite column. We're going to talk about why when we look at the book authors table. Okay. The third normal form is everything must be in the second normal form, and non-key columns cannot depend. So what it's saying here is when we have in our database, we'll have a bunch of columns, and one column is going to be the primary key, and everything's going to depend on that, right? And then we'll have something called foreign keys. Foreign keys are connections between tables to ensure data integrity, and they depend on each other. So when we look at it, and I'll show you in a second, we have our books table and we've got our authors table, two separate tables, and then we're going to put a table between them that allows the book ID and author ID to mix so we know who the book authors are, right? It'll make more sense in a second. Just follow. So I have a title column in the book table. Nothing can be dependent on that title column because it's not a keyed column.
Yeah.
Okay. So we don't want dependencies between the tables on anything that's not keyed. Okay.
Oh, and
And
that's
what,
what
what
no transitive dependencies is?
yeah,
Okay.
yeah, yeah, that's what that is. Okay. So and once you see it in action, it makes a lot more sense. And the truth of the matter is, the reason why it's not talked about a lot in field or in the real world, as it were, is because it should just be
Like
instinct.
self-evident.
Yeah. As you're building that, you go, oh, I can't do this. Oh, I can't do that. I got to make sure it's working out that way. Okay. So that's the three normal forms. So let's look a little bit here. Okay. So I have my self-indulgent database. It already exists. It's already here. I've already got a book table and everything's already here. So I'm going to make an authors table because I can't put the author information in the books table because it wouldn't be normal anymore because it's not that we know that every book has an author. And if we were guaranteed there was only one author for every book, we'd absolutely just put it in the books table. But we can't guarantee that. Some books have like up to 15 authors, like textbooks. So I'm going to create this authors table. Okay. So now I've got, let me go over here and populate my authors table. And let me populate my books table if it lets me get an error here. Actually, let me do this real quick first. You know what? Let me just recreate the table. Normally you wouldn't do this, but I know there's data in there and I want this to get dorky. Okay, so that table's gone. So let me recreate the table. Okay, and then let me populate the table over here. Okay. So now I've got a fully populated table. So now I need a way to, and so look, so notice here, my primary key is book ID. Okay. So this is the default column of the database, of the table rather. Everything's gonna be ordered by book ID. Author ID is my primary key here. Okay. I need to connect the two tables. So I have a reference point that shows me who the authors and of the books are. So
Mm.
by making a separate table called book authors, okay, I have book ID and author ID. And what's going to happen is when I insert the data into the tables, I'm going to take the book ID and the author ID and put them in that table. And then I'm going to make that the primary key.
Oh, so the combination of those IDs is one number.
Yeah. So it'll be one entry. So the two columns will be one entry because the primary key has to be unique, right?
Mm.
And so I will
Hmm.
never have an incident where the book ID and the author ID are the same because I only got to put that in there once and it's good to
Mm.
go.
Okay.
Um, and then I'm putting here, I got foreign keys. Okay, so the primary key is the main, it's the one that guides this table here. Okay. The foreign keys, I have foreign key, book ID, references, books, book ID. So what this is saying, hey, the column here references the column here. So what that does, it sets up referential integrity because I can't put anything in this table that's not in this table.
Huh. So you can't create like a fake entry in your book authors table?
Correct. Also, when this is in place, I can't delete anything from here that's also in here
Ah.
because we don't want orphaned rows.
Mm-hmm.
So if I just randomly dropped from deleted from books, they would leave off, they'd leave orphans here. We'd have nothing to do with. Same thing here. Or from foreign key author table, author key from books authors to the author table. So the same thing's going to happen here. Those guys can be connected. I can't insert from here that's not in here, and I can't delete from here that's not in here. I can delete anything I want from here. That's not a big deal. That's
Mm.
that's a Tuesday. Because if I'm deleting from here, it's not affecting this table at all. But if I delete from here, it's leaving orphans here.
And so this is what allows you to do multiple different author book
Yep,
combinations because no matter the way you put it, it'll always be different.
exactly,
Mm.
exactly. And that's what it comes down to. But this is what normalization is coming down to. So I've got this table that's just book names. It's book names, it's the title, it's the genre, it's the price, the stock count, it's everything that deals with the book that is unique to that book, right? The author may not be unique to that book because there might be two authors, there might be three authors.
Yeah.
The author table has everything that's unique about the author, his name, their his or her name, their birth date, their where they lived, where they grew up, whatever information on the author in there, because it's unique to them. And then I've got this table here. This table here allows, so when we talk about when we're talking about combining tables, we're talking about joins. And there's three kinds of joins. There's a one-to-one, a one-to-many, and a many-to-many. Okay. So um ultimately at some point so if I want a one-to-one relationship means one item in one table will only ever relate to one item in another table.
Yeah.
Okay. That's one to one. One to many is one item in one table will relate to many items in another table. So here in book authors, one book might have many authors. One author would write many books. So if I just do one way, one book would have many authors. That would be the thing. So like Yeah. So that'd be like one to many would be, so if I made a genre table, so I've got genre here as a column here, right? If I had a genre table, one book will have one genre, but one genre has many books. That makes
Ah,
sense.
yeah.
Yeah. Okay.
Yep.
And we would make, hang on a second. And we would make, ultimately, we would make a genre table. We're going to get that to another time. But say we're not getting tired, but we would make a genre table because the other reason why, um, so we create join these tables separately and join them together to do referential integrity and to allow, because book to authors is many to many. One book has many authors. One author has makes many books, and you can't do a many to many join between two tables. You've got to have this intermediate table there. Did I create this one yet? I didn't create this one. Let me create this. Okay. Um, if I were to create a genre table and connect it to and take it out of here and connect it to the books table, it's not because one book has many genres and many genres has one book has many genre and one genre has many books. It's not that. There's another type of data and referential integrity that we got to deal with. Um, we want to make sure that the data goes into the database, goes in the right way, the right time, and in the right manner. If I had a screen I had an employee that was adding new books as they came into inventory, right? And I just had a text box for them to type in the genre. They might misspell things. They might do something wrong. They might, add a genre that doesn't exist. So instead, what we do is we create another table called genre. We foreign key it to books. And then on that web page or whatever page is, there's a drop down list and they pick the genre.
Mm.
Okay. So we have to when we're creating databases, we're not only making sure the data is connecting probably to itself, we're making sure that end users, God love them, can't corrupt the data because that's what they want to do, whether they know it or not. So let me insert into the book authors table. Okay. So now I've got three tables here. Refresh. Okay, I've got three tables here. So what I'm gonna do right now is I'm gonna show you how to make an ERD or get your ERD out of this. So I right click on shelf indulgence. I've got, no, I go up here I click on the database. I go to database. I go reverse engineer. Okay. And it's going to bring up this screen. It wants to connect to your server. I click next. It's connected successfully. I click next. It wants to know what database you want to do. I'm going to choose shelf indulgence. Click next. Click next. And what it's going to do now, I click execute. It's going to create the diagram for the database. And that's my ERD. And here we can see the joins. So here's my books table. Here's my book authors table, here's authors. And when I click on the ID column, when I click on this link, it shows me what the foreign key is.
Mm.
Okay. So let's take that idea out here and let's make the genre table. So I want to go over here and I'm going to grab a new table and bring it over here. Okay. And this is how I recommend you can just design it from scratch in here. So I've got this. I'm going to double click the table here and the things that come up on the bottom here to input the data. I'm going to call this genres. Okay. I'm going to give it a genre ID. I'm going to make this tiny int because there aren't that many genres. And then I'm going to give it a genre name and just leave it at that for now. Okay. Make this not null. All right. So I want to link this table to this table. So over here, I've got these um, connectors. I've got one to one, I've got one to many, and I've got many to many. I'm going to take my one to many, and I think it's this way. It is. So what I've done is I've connected these tables. So genre ID showed up here. I'm going to delete this genre because I don't need it anymore. And now these tables are connected. It's a one-to-many relationship. One of genre has many books. And so that ID exists here. This is not to worry about the many-to-many. This just makes sure that end user can't type in the wrong genre or create a new genre name. Okay. Now, because I created it here does not mean it exists over here and here. If I refresh this, it's not there. So in order to get this over there, I've got to create the code.
Hmm.
So go here to database. I go to forward engineer. This screen comes up, it just connects. I click next. I don't want to here I do want to skip the generation of index statements, foreign keys. You don't want to skip anything. You click next. I want to export all of the tables to that. Right? We have no other we have no other here, so just do that. And then here's the code. And if I scroll down, there's my genre database.
Hmm.
Okay. So all this exists here for to do. Okay. So that's part of the final project. So design it here, make the code, bring it over there. And by the way, I'll say this now. I'll say it. If you do the final project, and I hope that you do, when it comes to writing the insert statements, the trick that I've encouraged people to do, because writing insert statements is because these are insert statements I had for today, right? Where are they? Where'd they go? These here, right? I didn't write these. Um, I went into AI, I gave it my schema, and I said, write me 50 insert statements for each table. And because it has the schema, it can write the insert statements without a problem. Obviously, if you're doing this for real, you wouldn't do that because it wouldn't know the data you have to put in. But because I just need to generate fake data, it's easy enough to do. So that whole section about insert statements, absolutely lean on AI to do that. Okay. So does it all make sense? Okay. So now what we're supposed to be doing tonight, the app's plan. So that's all that. So we talked about normalization. We talked about creating tables here. We talked about foreign keys and primary keys. There's other constraints we're going to talk about later, but these are the ones you need to know for today. Now, here's the question. If I want to get a list of all the books and the authors, how do I write that query? How do I get the data from here to link up with what's here? So there we are. If you remember back to grade school, there were Venn diagrams. So writing queries that pull data out of all the tables comes down to the Venn diagrams. There are four kinds of joins. There's cross joins, inner joins, right joins, and left joins. Cross joins we're going to talk about later because they're stupid and no one should use them. And you'll see why when I show you them, because you'll go like, why would anyone do this? I've been doing this 23 years now. I have no idea why anyone uses a cross join. Inner join is when you've got two tables. What the heck happened there? Inner join is when you have two tables and you want the data that matches between them. Only where there's data for both of them. Okay.
Hmm.
So here, if I'm writing book authors, so let's say this one's books and this one's authors, right? That's a horrible color. This one's book. There we are. And this one's authors. I only want an inner join shows me all the books that have authors and all the authors that have books. If there's a book without an author or there's an author without a book, it's not going to show up in that query. Right? When we're talking about right and left joins, Well, let's go through examples for inner joins, and then we get to right and left joins. I'll show you the examples of that. So go back over to our thing here. Okay. So here I've got so here um I just want to see which book IDs belong to an author. So here I'm going to select from book authors, right? Book ID, and see this BA here and this A here. When I'm doing joins on tables, like last week, we just did regular join, we just regular queries, and we are from one table. We're pulling from multiple tables. When we pull from multiple tables, we have to use this from join combination. And you see after the table name, there's an alias, BA or A. This is because when we're using multiple tables, whenever we call out a column, we need to tell the query where to find that column. And if both tables have the same column, I got to tell them which one to look at, right? Or what I'll get is an ambiguous query. So if I run this, what it should happen. So if I run this like this, oh, I should have got an ambiguous query out. Oh, it's because I'm using, oh, hang on a second, because I'm using authors. That's why. So let me get rid of this one. This should give me the error. Nope, still give me the error. I should be getting a error that says uh what is it? Ambiguous query. It doesn't know which one it wants to do. But regardless. So with this one is it's getting book authors, it's joining to authors on the column that we're on the foreign key, and it's returning where these two are equal. So when I run this, you'll see the results again. Now I just have book one belongs to F. Scott Fitzgerald, two and three Brandon Sanderson, three and four George Orwell, so on and so forth. Um, and the same is true if I just want to join, if I want to get the title and the author's ID, I can do the same thing. Okay. So what I'm doing is I'm querying the books table or the authors table and the book authors table and give me the information in both of them. But um what if I want the name of the author and the name of the book together? So I actually have to join three tables together. So here I'm joining books to book authors on book ID, and I'm joining this query, this combination, I'm joining that to authors on author ID. So what's happening there is it's going to tell me, it's going to show me every book that an author has, and every author that book that has an author and author has a book. So we look here, and now I'm getting the names. This information is stored in three tables, but I'm presenting it as one table because that's what the user will understand.
Hmm.
Um, okay. So now let's look back here. I have right joins and I've got left joins. A right join is when you take the table that's on the right side. This is a left join. That's a left join. And this is a right join. Okay. Is when you take the table that's on the left side and show all the data from that table and the data that matches from the right table.
Hmm.
So if this is book and this is author, I would say show me all the books. And if there's a book without an author, show me that, but I'm going to have a null where the author name would be.
Hmm.
Okay. If I do a right join for books and authors, it'll say, show me all the authors. And if there's an author that doesn't have a book, show me null.
Hmm.
Okay. So it's kind of a quick check to make sure that everything looks the way it's supposed to. So let's go back over here and look. So here I've got I'm selecting author name and book ID from authors. I'm linking it to book authors on author ID. but it's a left join. So I'm gonna see if there are any authors that have no books, and they would be at the bottom. Yep. See, Emily Dickinson have a book, Langston Hughes, Walt Whitman, Dr. Seuss, and Shel Silverstein. We don't have any Shel Silverstein books. That is a problem. We got to fix that.
Rest in peace.
I know. He's good stuff, man. I love his sarcastic take on children's poetry.
Yeah.
The Giving
Yeah.
Tree is a beautiful, it's a beautiful story, but you're like, wow, that is, that is what it is to be a parent. Um, anyway, I
At least you have
digress.
C.S. Lewis books, though.
Oh, the C.S. Lewis, he's a whole different, he's different, a completely different dude.
Oh, yeah.
There's 48 of his books there too. So wow. Anyway, so we left joined authors to book authors, and so we now know what authors don't have books.
Hmm.
I can do the same thing in reverse. So here I'm doing this. Um, I'm finding only the authors who have zero books in our system. So I'm selecting the author name from authors, left joining, but now I've got where book ID is null.
Oh, yeah.
Okay. So this is the same query as up here, right? But now I'm just getting their name and seeing who has no books. And there's our names again. Okay. So this query here, we're doing two left joins. So we're finding all the books, their stock levels, linking to the authors if they have one. Now, normally you could just do this in inner join. We're just showing off by doing two left joins. So here what I'm doing is I'm taking title, stock count, and author name from books. I'm left joining to book authors, and then left joining to authors. Okay.
Oh, cool.
Okay.
So just a quick question on these
Sure.
queries.
Hmm.
I noticed that the aliases are defined after you use them in the select statement. Is that
Yes.
accurate? Okay,
Yes.
interesting.
Because remember, I don't know if you heard last week, the select statement is the first thing that runs. I'm sorry, the from statement. So here, this runs first. When
Ah, gotcha.
so all the aliases are defined prior to the select part running.
So certain, I don't know what you call those commands like select from, left join, whatever. There's a
Clauses.
certain clauses that were called. Yeah. So certain clauses execute in a certain order in a
Right.
query. Okay.
So when we talk about when we talk about last week, you had select and from. The from goes first.
Oh yeah, I do remember this
Mhm.
now. Sorry, it has been quite the week. Yeah,
I
I do remember this now.
I'm with you. Yeah. So just and it's a good refresher. So the from goes first because the query has to pull all the data sitting on disk, which means you can't touch it. It's got
Ah,
to be in RAM. So the from runs first, grabs all the data from the tables into the hard drive and puts it into active memory.
gotcha. Because you can't take a bite out of something you don't have on your plate.
Exactly. Exactly. That's a way better analogy. It's a food analogy. I like that. I usually say you can't read something that's in your filing cabinet.
That's also true.
Yeah. So yeah. So here. So again, let's look at this one here. I'm selecting a distinct author name. So distinct is a command that says if seven return, just show me one. I don't need to see all seven.
Hmm.
So if I got seven instances of Sylvia Plath, just show me one. I don't need to see all of them. So here I'm. Oh, I broke this one. This isn't going to work because I got rid of that column. Oh no, I didn't. I didn't query it. So this is the genre column is still in the table. I didn't change the database yet. So here I'm saying show me the distinct author name from authors joining two book authors and books where the genre in books is fantasy. So I'm getting data from the authors table based on a column in the books table through the join.
Hmm. Mm-hmm.
So I run that, and there's five of them. If I got rid of the distinct, I got
Mm.
yeah, so that
Because
just
for every instance of a book that has them, you're
yep,
gonna get it, which is why you don't really care about getting duplicates because you just want to know
exactly.
how many unique authors there are. Okay.
Exactly, right. Right,
That
right.
makes sense.
hmm So let's look at So these are my intermediate queries. So here, I'm going to get the book title, the author's name, and the price of the book from books. And I'm doing the same joins I was doing before. So it just says join here. When you just see the word join, it means interjoin.
Okay. I was
Okay.
gonna ask about that,
Yeah.
yeah.
It's by default, it's interjoin. Um, and again, I'm getting these three pieces of information through the three tables based on a column in the books table. So I want to get every book, book title, author name, and price for books that are over $20.
Hmm.
Action Comics number one is not $2,500. It last sold for $9.8 million dollars.
Whoa.
There's only like 14 of them in the world. Or is it 22 now? Funny sidebar story about Action Comics number one. Obviously first appearance of Superman.
Heck yeah.
June 1938 it came out. People weren't collecting comics back then. They were reading them, putting in their pockets, throwing them away.
Yeah.
So there aren't a whole
Mhm.
lot of them around. And the ones you find are not generally in the greatest conditions because A, they're what, like 90 years old at this point? Was it 20? So like 80 years old or give or take. And they were folded up. So about 6 years ago, there was a family whose grandparents had just died, and they had a house that was about to be foreclosed on because they didn't have a lot of money. And they were cleaning out grandma's stuff, and in the attic they found a dresser, and in the top drawer of the dresser was a copy of Action Comics number one.
No way. And did they sell it?
Oh yeah, yeah. They took it to the bank and said, "Hey, can you hold off on foreclosure because we're about to sell this comic?" And the bank's like, "Yes." So they had it graded. It graded at a 9.2, which is the highest grade ever on an Action Comics, and it got like $10.5 million.
Holy cow.
I don't know why I'm never allowed to find stuff like that in my attic, mostly because I don't have an attic living in Florida.
Yeah, I need this luck to find me.
I know, right? I promise I'll be good with the money, not do stupid things.
Yeah, same. I
A
promise.
couple stupid things, but
Only
um,
minor stupid things.
nothing that's gonna hurt anybody, right?
Yeah, yeah, totally, totally.
Yeah. So anyway, so this is another advance. So here, look at this one here. I'm getting the title, and I'm going to put some aggregates in here now. I'm going to the count of authors as author count from books where author count is over one. So I want to find all my books that have more than one author.
Oh,
Okay.
gotcha.
So here I got. So again, have we talked about? Oh, we might have talked. Oh, I'm doing things. I'm doing things differently this semester. I usually talk about. I'm trying different to keep it interesting for me. I'm doing different cadences on when things are taught. So a count command, the count clause here, it's an aggregate function. So it just gives me the count of what's going on here. So here I'm going to get the book, and this is going to count how many authors are with it. So it's just a number that's going to be returned. Okay, it's like a math function. We'll talk more about this later, but that's what it is, an aggregate function. And then returning that, and here I'm giving it a different name. So this column will now be called author count. And whenever I have an aggregate function, I've got to use this group by clause. Because this is a math function and this is not a math function, I've got to tell the query what we're going to count this off of. Like, how do I know to make that count from? So I'm going to do by title. Any column that is not in the aggregate needs to be in a group by. So here I'm going to get the title, the count of the authors as author count from the same three, grouping by title, having an author count greater than one. And there's only one. That's good omens. Okay. I can find all the books that start with the word the. Same joins. I'm just using where titles like the. Here, I'm going to get the total of the potential value of all the books in my store based on author name. So here, I've got the author name. I'm using the the clause sum. So what's going to happen with this? In the books table, there's a price and a stock count, right? So it's going to multiply the two of them together in every column and then add them all up based on the author name. Same from clause. All I got a group by here by author name, and I got the sum query here. And so, we got $760 worth of George Orwell books, 1,200 versus J.K. Rowling, and so forth. Okay, I'm gonna skip this one. We can talk about this one. No, I'm gonna skip this one for right now. Don't look at that one. There's a whole, I think it's in week 4 or 5. There's a whole conversation about self-joining tables, and we're at 10:30 already, so we'll get that one later. Let's get this last two here, these two complicated ones. So here, I'm getting the distinct author name from authors, where the genre is classic, and the author ID. Um, so what I'm looking for is the name of the author who has classic books but has never written a horror book.
Hmm.
Okay.
Oh, okay, yeah, I see that in the query. Yeah.
Yep. So here from classic, and the author ID is not in the same query, but using horror
Yeah.
instead.
Yep.
And not in means not in there. So when this runs, these are all classic authors who never wrote a horror story. Charles Dickens, technically, Christmas Carol is a horror story,
Hmm.
but not anymore. Back then it was.
Yeah. Yeah, I remember seeing the older ones. They were
Oh, that one with Jim Carrey, that gets downright creepy.
yeah, it does. But the
All right.
new one on Netflix, the songs go pretty hard. It's pretty
Yeah.
fire.
Have you seen on Apple TV? It's not called Scrooged. What's it called? It's the one with Ryan Reynolds.
Oh, I know what you're talking about. I haven't seen that one. Is it good?
Oh yeah, it's hysterical. It's Ryan Reynolds and Will Ferrell. It is
Dude, that's
so
funny. I know which
funny.
one you're talking about.
Yeah,
That looks hilarious.
I can't remember. Yeah, it is very funny.
That's
And the good thing is Ryan Reynolds is generally his language isn't the best in the world, but that movie and the movie Big Guy, where he's a video
funny.
game character,
Mm-hmm.
also fantastic, hysterically funny movie. Anyway, sidebar.
No,
Okay,
you're good.
last one here. Okay, we're getting the author name, the count of the books that they have in stock as the total volume of books. And I'm getting it where the price is between 30 and 10 and $30, and the author's name does not begin with an S.
Hmm.
And I'm only getting the top three. So three results, and that's that. Um, oh, the names start with an S. Wait. Oh, it's not like S. So it's the first name.
Yeah, first
So
name, yeah.
yeah,
Brandon,
yeah,
JK, and
yeah.
CSS.
Yeah, it caught me off guard there for a second because I forgot it wasn't two different columns for normally first name and last name is two different columns, but
Yeah,
that's
that's
fine.
true.
Anyway, so this one here just shows we can get incredibly granular with this stuff, like comically granular, with what we're trying to do. But that's the thing, if we need to do a report by that, like, what author do we have the we want to have since we have 75 Brandon Sanderson books, maybe we have a sale on the Cosmere, or whatever it is. Um, so so when we're looking at how we join things and this is all about how we take those databases and those tables and get the information out because we've normalized it. And when you look at it, you've got information everywhere in like 10, 15, 20 different tables, but you got to bring it back into one expression so the customer can see what they're looking for, or you can see what they're looking for. All right. Any questions?
Honestly, I don't really have any questions. I did take one intro to database class, and
Mhm.
so far everything that's been covered Like so far it's repeat, but it's only because it's like week 3. So
Yeah.
I think we'll get more
Well,
advanced as it goes.
y- y- so we will. The book doesn't.
Oh,
Um,
interesting.
so the intro to database class and the class we're in now, they kind of some things we talk about. Like, did you do case statements?
Hmm.
Yeah. So all the code we talk about is the same. The only thing we're talking about here is the difference of like how to design, manipulate the data rather than just how to just run the queries.
Yeah, as I
But
say, it was very focused on, I think it was, yeah, it was very focused on queries, not as much on database
yeah.
design. But
And so this class used to not be focused on database design, but they gave me the freedom to change it. So we focus more on database design. And we'll talk about things in this class like the index theory, like how indexes actually work.
hmm,
Behind the scenes. We'll talk about we did 25-minute discussion last week on data types, which isn't in the book anywhere. We're going to talk about how to create stored procedures. We're going to talk about how to do a bunch of stuff.
cool.
Um, that's not in the book. And really it's just because if you're gonna I was talking to someone else about that today, if you're gonna come here and spend an hour with me on Tuesday night when you can do something way more interesting, I'll make sure you get some information that you won't find in the book anywhere.
Yeah.
So, all right. Then thanks for coming by. I appreciate it.
Yeah.
And I'll put all the video out there and everything, and then I'll see you next week.
I will be here next week.
Hey, thank you.
Thanks. Have a good one.
You too. Bye.
We'll see.